Alright, section 4.2, apply congruence and triangles. Congruent figures. Alright, all parts of one figure are congruent to corresponding parts of a second figure. And again, congruent means same size and same shape. Parts, we're talking about angles and sides. Corresponding, we reference corresponding parts here. What are they? They're the angles or sides that are in the same position in two or more figures. Alright, two acronyms here. Essentially mean the same thing. CPCFC, corresponding parts of congruent figures are congruent. CPCTC, corresponding parts of congruent triangles are congruent. Alright, so when we know we have congruent figures or congruent triangles, the corresponding parts are then also congruent. Okay? You will hear us talk about something called a congruence statement. This is an example here of a congruence statement. Triangle ABC is congruent to triangle DEF. Alright, so with your congruence statement, we can label our triangles. So I have my two congruent triangles down here. Alright, and I have another acronym for you, 2T-POM, two triangles pulled out and marked. So you're putting them in original position and corresponding position. Okay? We have triangle ABC. Alright, now which point corresponds with A? Alright, and that's the one that's in the corresponding position. That's D. So lower left, D has to be lower left. B corresponds with E. That's on the top here, so E has to be on the top. And lastly, C corresponds with F. C's on the lower right, so F must be on the lower right. Okay? And if the two triangles are congruent, that means that angle A is congruent to angle D, angle B is congruent to angle E, angle C is congruent to angle F. Same thing, segment AB is congruent to segment DE, segment BC is congruent to segment EF, and lastly, segment AC is congruent to segment DF. Alright? So from my congruence statement, I can pull up my two triangles and mark them as such. Alright, write a congruent statement for the triangles. Identify all pairs of congruent corresponding parts. So again, we want to put these in corresponding position. So if I call this my original position triangle, that means I have to have one that looks the same as that one. So, it means I have a right angle here. This is my corresponding position triangle. I have a single mark there. I have a double mark here, triple slash, single arc, and then a double slash. Alright, now my corresponding triangle. How do I label it? Well, I know my right angle is F, so F goes here. I know the single arc is G, so single G, and the double arc is H, so H has to go up there. So now we know which parts correspond with which parts. Triangle ABC is congruent to triangle F, and B corresponds with G, and lastly C corresponds with H. And there's my congruence statement. And again, the congruent parts, angle A is congruent to angle F, angle B is congruent to angle G, angle C is congruent to angle H. Same thing, segment AB is congruent to segment FG, segment BC is congruent to segment GH, and lastly, segment CA is congruent to segment HF. And you can get that from your congruence statement or from the diagram. Alright, now we're just talking about congruent figures. We don't have triangles anymore. Okay, this does apply for, in this case, quadrilaterals. Figures with more than three sides. Alright, so we have our congruent statement. So we know which points correspond with which. So I'm taking this as my original position figure. And now I need one that is in corresponding position, which means it looks something like this. Alright? Now, point Q corresponds with W. Q is in the lower left. W has to be in the lower left. R corresponds with X. There's R. X has to go up here. S corresponds with Y. And then lastly, T corresponds with Z. T is in the lower right. There's Z. Now looking at my original figure here, label my parts. Segment WX is y minus x. So segment WX is y minus x. Angle W is 5x plus 5. So we got 5x plus 5 for angle W, degrees. Okay? Now find the value of x and find the value of y. If the figures are congruent, their corresponding parts are congruent, like here. Okay? That means angle Q is congruent to angle W. And if angles are congruent, we know their measures are equal. So the measure of angle Q equals the measure of angle W. The measure of angle Q, 65 degrees. The measure of angle W, 5x plus 5. We've taken a geometric concept to set up an algebraic equation. Now solve. So subtract 5 from both sides. We get 60 equals 5x. Divide both sides by 5. X equals 12. Find the value of x. Did that. Part B, find the value of y. Again, we have congruent figures, so their parts are congruent. So segment QR is congruent to segment WX. And I know I need to use that because there's y there. It talks about segment WX. Alright? And if the segments are congruent, their lengths are equal. So the length of QR equals the length of WX. The length of QR is 6. The length of WX is y minus x. And again, we know what x is 12. So y minus 12. Add 12 to both sides. So 18 equals y. Alright, here we know the figures are congruent. Figure FGHJ is congruent to figure STUV. Identify all pairs of congruent corresponding parts. So the first thing we want to do is put them in corresponding position. I have my original position figure. That means I need to have one that's in corresponding position. Right angle there. That's about all I know. I know the right angle is U. Okay, now for my congruent statement, angle F corresponds with S. S needs to go up here. G corresponds with T. H corresponds with U. H and U, yep, we're good. And J corresponds with V. There's J and there's V. Okay, now identify all pairs of congruent corresponding parts. So congruent angles. And I'll give you one example and I want you to finish the rest. Alright, we know that angle F is congruent to angle S. And list the rest, the last three. As well as the congruent segments. We know that segment FG is congruent to segment ST. And again, those are corresponding parts. The figures are congruent, the corresponding parts are congruent. Corresponding parts of congruent figures are congruent. So please finish up those, the corresponding parts that are congruent, as well as finish up defining the value of x for the measure of angle G. Find the value of x and find the measure of angle G. So do that in your notes for tomorrow. Third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are what? Well, if you think about a triangle, what do you know? We know the angles add up to equal 180 degrees. Not only in triangle ABC, but also in triangle DEF, right? And if we have these two angles congruent to those two angles, I don't care what value those two angles add up to equal. Say it's 140 degrees they add up to equal. What does angle C have to be? Has to be 40 degrees, right? Well, if these two angles add up to 140, what do angles D and E add up to? They also add up to 140, right? Because they're congruent to these two. So, if those add up to 140, angle F then has to be 40 degrees as well. So there, we know then, the third angles are also congruent. So third angles theorem. If two angles of one triangle are congruent to two angles of a second triangle, then the third angles are congruent. And at any point, if I'm going too fast, please pause the video, rewind it, whatever you need to do. All right, a proof here. Okay, we have our statements. We have our reasons. Okay. And the other thing we need to do here is I'm going to put original position triangle, and I need a corresponding position triangle. So I need my triangle to look like that. So I need a double arc here, I need a single arc, single, double. So my corresponding position triangle, how do I label it? Well, the double arc is point G, so G has to go over here. The angle that has nothing is J, so J goes down here. The single arc is H, so H goes up here. Alright, so now I kind of ignore my original diagram here. Alright, so first given, segment FH is congruent to segment JH. That's given. FH congruent to segment JH. It's already marked. Okay? Second given, segment FG is congruent to segment JG. Again, that's given. FG is congruent to JG. Mark your triangles. Two triangles pulled out and marked. Number 3. Angle, let's go back. We have two pairs of sides. Can we get the third pair of sides congruent? Okay, if we look at this original diagram, we see the two triangles are sharing the side. So that segment is the same segment in both triangles. So segment HG is congruent to segment HG, isn't it? That is, congruence is reflexive. So 1, 2, 3, 1, 2, 3. Now we have all pairs of sides congruent. Now angles, can we get those congruent? Well, we have angle FHG congruent to angle JHG. That's given. FHG and JHG. FHG, that's this angle, and that angle. Yep, they're congruent. Angle FGH is congruent to angle JGH. That's given. Okay, angle FGH and JGH. Double arc, double arc. Now, can we get the third angles to be congruent? Well, we just learned about up here the third angles theorem, right? And we can use it here. Angle F is congruent to angle J. Why? If two angles of one triangle are congruent to two angles of a second triangle, then the third angles are congruent. So we mark those. So now we have three pairs of sides, three pairs of angles. What can we say about our triangles? All the parts are congruent, right? Three pairs of sides, three pairs of angles, so therefore then the triangles are congruent. Triangle FGH is congruent to triangle JGH. If all corresponding parts of one triangle are congruent to a second triangle, then the triangles are congruent. Okay? If you can show that all the corresponding parts of both triangles are congruent, then the triangles have to be congruent, because all the pieces are congruent. Alright, reflexive, symmetric, and transitive. Okay, we've used those for segments and angles throughout. The same thing applies. Reflexive, something is congruent to itself. So triangle ABC is congruent to triangle ABC. It's congruent to itself. So the Idea of reflexive has not changed from segments, angles, and now to figures, in this case triangles. Symmetric. If triangle ABC is congruent to triangle DEF, using the symmetric property, that means we can switch it. Triangle DEF is congruent to triangle ABC. Okay, symmetric means you can switch it. And lastly, transitive. If triangle ABC is congruent to triangle DEF, those two triangles are congruent. And triangle DEF is congruent to triangle JKL. Those two triangles are congruent. Okay, what can we conclude? Again, transitive has not changed from when we talked about segments, angles, and now to triangles. Two different things congruent to the same thing, therefore they are congruent to each other. Triangle ABC is congruent to triangle JKL. Alright, here's a proof I want you to do for tomorrow as well for practice. Alright, here's your givens. E is the midpoint of segment AC and segment BD. Segment AB is parallel to segment CD. Segment AB is congruent to segment CD. Can we prove that the two triangles are congruent? And remember, at this point, we need to show all angles and all sides are congruent. So you need 6 things to be congruent before you can say the triangles are congruent. In the next few days, we'll be learning some shortcuts where you don't need as many. But right now, we need 6 things. Alright? Thank you very much.